right, let's get right into it. Today, we're tackling one of the biggest questions in AI for any business out there. How do you take one of these incredibly powerful, general-purpose, large language models and turn it into a true, specialized expert for your company?
I mean, think about it for a second. The AIs making all the headlines are trained on, well, the entire public internet. They're amazing at general knowledge. But what did they know about your internal code base, your specific project docs, the acronyms and jargon that only your team understands? And that's the real gap we need to bridge.
And this really gets to the core of the problem. You can have a powerhouse model like Llama that knows a trillion facts about the world, but it is completely 100% clueless about the private, proprietary universe of your company. It's never seen your internal wikis, it hasn't read your support tickets, and it definitely hasn't peeked at your private code repos. So why is this such a big deal? Well, for starters, sending all your sensitive company data to some external API is a huge red flag for privacy. Not to mention, the costs can get pretty wild. The real dream for most companies is an AI that lives on-premise, one that gets their specific context, feels custom-made, and gives you high-quality answers instantly. You don't just want a smart AI, you want an AI that feels like it's part of the team. Okay, so how do you actually do that? How do you teach an AI all this new, specialized stuff? Well, it turns out you really have two main paths to go down. The first method is called RAG. Think of this as giving the AI an open book exam. You give it access to a library of your documents, and it can look things up on the fly to answer questions. But, and this is key, the model itself doesn't actually learn anything new. The second path is fine-tuning. This is like making the AI actually sit down and study the material. You're retraining it on your data so it absorbs that knowledge, and its internal wiring, its parameters, are fundamentally updated. Now, RAG is pretty quick to set up, but it has a big catch. Its answers are only as good as the documents it can find. If its search system pulls up the wrong info or nothing at all, the AI is basically helpless. And that's why studies show that for really specific, domain-heavy tasks, fine-tuning often comes out on top. It just produces more accurate, more succinct answers because that knowledge is baked right into the model's brain. Awesome. So fine-tuning is the way to go, right? Well, that brings us to the next massive hurdle. If it's so great, why isn't everyone just doing it all the time? It really boils down to a huge dilemma involving cost and resources. And the scale of this problem is just staggering. To give you some perspective, just to load a pretty small 7 billion parameter model's weights into memory, you need around 28 gigabytes of super expensive GPU RAM. And that's just to get it loaded. That's before you even begin the training process, which needs even more power. The hardware barrier to entry is just incredibly high. But this is where a really clever solution enters the picture. PEFT, which stands for Parameter Efficient Fine-Tuning. The idea behind it is actually pretty brilliant. It asks, instead of trying to retrain all billion-plus parameters in the model, what if we just didn't? What if we froze almost all of them and only trained a tiny, tiny fraction? And the most popular way to do this is a method called LoRA. So imagine the giant AI model is this massive, complex machine that's basically unchangeable. LoRA doesn't try to rebuild that whole machine. Nope. Instead, it just plugs in these small, lightweight, new adapter modules that are super easy to train. So this is what the process looks like. Your new data, all your company documents and code, flows in, but that huge pre-trained model, the big blue box, stays completely frozen and untouched. The only things that get updated are those small, lightweight LoRa adapters. This makes the whole thing way faster, way cheaper, and requires so much less memory. On the surface, it really seems like the perfect solution. But you know how it goes in the world of tech. The seemingly perfect, elegant solution, well, it isn't always quite so perfect, and there's a really surprising twist when it comes to performance. So, does all this incredible efficiency mean that LoRA is the final answer, the go-to solution for every single use case you could possibly have? The data suggests we need to pump the brakes a little bit. This quote from a really important research paper in the community just cuts right to the chase. In most head-to-head showdowns, LoRA actually underperforms a full fine-tune, sometimes by a lot. And that brings us to the most important question of all. Why? Well, it really boils down to a few things. First, by its very design, LoRA only makes small, targeted tweaks, which might just not be enough for a really complex new task. It also acts like a guardrails on a highway.
It keeps the model from straying too far from its original knowledge, which is good for preventing catastrophic forgetting, but it can also stop it from deeply learning a new, complex subject. A full fine-tune, on the other hand, is like removing those guardrails. It allows for much deeper, more complex updates to the model's core understanding of the world. And this leads us to what is maybe the most important lesson in all of this. When it comes to AI, there are no silver bullets. There's no one perfect answer. Every single choice you make is a strategic trade-off.
Let's look at quantization, for example. It's another trick to shrink a model's memory usage. But look at this chart. As you reduce the precision to save memory, the time it takes to get an answer, the inference time, goes up. You save on one end, but you pay for it on the other. It's a classic trade-off, and they are everywhere in AI.
Okay, so knowing all of this, how do you actually pick the right tuning strategy for your project? Let's lay out a clear framework to help you decide.
Here's how it generally breaks down. You're going to want to lean towards LoRA and other PEFT methods when your GPU resources or your data are limited. It's also great if you need to spin up multiple different task-specific models quickly, or if it's really important that the model doesn't forget its general knowledge. On the flip side, you should seriously consider a full fine-tune when maximum performance is the #1 absolute top priority, when your task needs deep changes to the model's core logic, and of course, when you have the data and the hardware to pull it off. And finally, let's cover some pro tips pulled straight from the research papers. First, if you're using LoRA to teach the model new facts, the sweet spot seems to be a low rank and a high alpha value. Second, and you can never say this enough, your data quality is everything. Garbage in, garbage out. Third, you can save a ton of GPU memory just by loading models in half precision. It's usually more than enough. And lastly, if you're brave enough to try a full fine-tune on a single GPU, make sure you use a paged atom optimizer to help manage memory. It can be a lifesaver. So when you zoom out, the big takeaway is this. That journey from a generalist AI to an AI that is truly your AI isn't about finding some magic button. It's a series of careful, strategic trade-offs, balancing what's possible with what's practical. And that really leaves us with the final question for you to think about for your own work. What's more important? The speed and resourcefulness of efficiency, or the raw, deep power of maximum effectiveness? Only you can decide how you'll train your AI.